Okay, welcome back. We are finishing up here. Example 3, combined stretches and reflections. So we're going to do more examples, and we're going to dial up the complexity as we do these couple examples. So given the graph of y equals f of x, sketch the graph of g of x. Okay, so we're going to apply a transformation to f of x, which will result in g of x. State the mapping notation star all invariant points on the graph. So let's get going. So number 1. Okay, so up here, what kind of transformations do we got going on? So this time we have two kinds of stretches. So my A value equals 2, and my B value equals 4. Okay, so when A equals 2, I'm going to multiply all my Y values by 2. When B equals 4, remember B value is different than the factor. I have to do this to get the factor. Absolute value 1 over absolute value B. So that's 1 over the absolute value of 4. And that is 1/4. So I multiply all x values by 1/4. So multiply y values by 2, x values by 1/4. So number 1, let's transform the points. So in black, x, y. And I'll do this step by step. So point A, B, C, D, E. Okay? Point A, negative 8, 0. Point B, negative 4, 2. Point C, 0, 0. Point D, 4, negative 4. Point E, 8, negative 3. I'm going to do one transformation. I'm going to do the x value multiplied by 1/4. So it's a horizontal stretch about the y-axis by a factor of 1/4. So 1/4 x, y, and that transforms to negative 2, 0. So all the x values multiplied by 1/4. Negative 1, 2, 0, 0, and 2, negative 3. Okay, let's plot those. I'm going to plot those in red. Okay, so I have negative 2, 0, negative 1, 2, 0, 0, oops, totally forgot this one here. Sorry about that, folks. That's going to stay 0, 0. Okay, so that one I missed. So 0, 0. Oh, man. Let me fix that. All of that. Okay, this one is 0, 0. This one is 1, negative 4. Okay, there we go. 0, 0, 1, negative 4, and 2, negative 6. Oh, sorry, 2, negative 3. Okay, so 2, negative 3. So the first part of our transformation looks like that. So that makes sense. It's a horizontal stretch about the y-axis by a factor of 1/4. So it's going to stretch it by a factor of 1/4. So it looks like it's compressing it, right? Okay. And then the next transformation is the vertical stretch. So 1/4 x. The a value is 2, so it's 2y. So all the y values now multiply by 2. So negative 2, 0. Negative 1, 4. 0, 0. 1, negative 8. And 2, negative 6. Okay, these I will label in blue. Oops. These I will label in blue as A prime, B prime, C prime, D prime, E prime. Okay? All right, so A prime, negative 2, 0. Negative 1, 4. Okay, that makes sense. Vertically, we're stretching it about the y. Sorry, vertically we're stretching it about the x-axis. So it makes sense that from the red point to this blue point, it's doubling. Okay, so negative 1, 4. Okay, 0, 0. 1, negative 8. So 4, 5, 6, 7, 8. 1, negative 8. Okay, and then 2, negative 6. 2, 1, 2, 3, 4, 5, negative 6. Okay, so that's A prime, B prime, C prime, D prime, E prime. Okay? So sketch the graph. So we've sketched the graph. State the mapping notation. Here it is in full, step by step. And star all invariant points on the graph. So the invariant points right here in green and right here. Okay, so I have, oops, sorry, that is not it, just right here at C prime. Okay, and I'll write right here, invariant point at C prime, which is 0, 0. Okay, that point does not move through any of our transformations. All right, letter B. I have g of x equals negative f of 1/2 x. So let's do this one by one here. That is an a value equal to negative 1. I have a b value equal to 1/2. So this is all y values multiplied by negative 1. It's negative 1, so it's not going to stretch vertically, but it's going to be a reflection in the x-axis. Okay. This one, b value is 1/2. Remember, that's different than the factor. So I have to do 1 over the absolute value of b. So that's 1 over 1/2. So my horizontal stretch factor about the y-axis is a factor of 2. So I multiply all x values by 2. So let's show the mapping notation. So this is 1 and 2. So I'm going to graph it after I show you the points and the mapping. Okay, so I have x, y. So this is A, B, C, D, E. X, Y, I have negative 4, 2. So that's A. B is negative 2, 2. C is 0, 5. D is 2, 2. E is 4, 0. 2x, y. That is, so we're multiplying. Let's do the horizontal stretch about the y-axis. The mapping notation is 2x comma y. So all the y value, sorry, all the x values I multiply by 2. So that's negative 8, 2, negative 4, 2, 0, 5, 4, 2, and 8, 0. Okay. As a halfway, I'm going to graph that so you can see the piecemeal transformation. So in red, negative 8, 2. Right there. Negative 4, 2. 1, 2, 3, 4. Negative 4, 2. 0, 5. 4, 2. And 8, 0. Okay, so this is what, remember, this isn't the complete transformation. This is, oh, wow. Sorry about that. Negative 8, 2. Negative 8, 2 is here. Sorry, folks. Negative 4, 1, 2, 3, 4. 2 is right there. Okay. My apologies. And, oh, man, this one. 4, 2. Okay, I think we're good, right? Yeah. So let's join the points. Okay. And that's what it looks like in between. That's just the horizontal stretch about the y-axis. Let's do the vertical stretch about the x-axis. So now The a value is -1, so I'm going to multiply all the y values by -1. There you go. That's the mapping notation. So it's -8, -2, -4, -2, 0, -5, 4, -2, and 8, 0. Okay, let's graph that in blue. This is a prime, b prime, c prime, d prime, e prime. Okay, a prime, -8, -2, right there. -4, -2, 1, 2, 3, 4, -2, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 4, 2, 1, 2, 3, 4, 1, 2, and then looks like we have an invariant there at 8, 0. Oh, no, sorry, 8, 0. Okay, join the points. A prime, b prime, c prime, d prime, e prime. Okay, last part, star all invariant points on the graph. There are none. Invariant points means throughout the entire transformation from start to finish, there are no points that remain the same throughout. Okay? All right. Example 4, making equations. Okay, the graph of function y equals f of x has been transformed by either a stretch or reflection. State the equation of the transformed graph g of x. Okay. Okay, I'm going to do this. I'm going to check test points. So let's go f of x, and we know that's absolute value of x. And let's see what it transforms to when we go to g of x. Okay. And then we're going to need an equation eventually. Okay. So this is what I mean by test points. So here's f of x. I'm going to go 4, 4. We know that the vertex of both absolute value functions is the same. That's the invariant point. So if I pick a point on f of x there, if I go straight up, what does it transform into? That's 4, 12. Okay, if this is x, y, folks, how do I write this with mapping notation? That's x. What do I do to the 4 to get a 12? That's 3y. This is my a value. Okay, I don't see a reflection because the graphs aren't flipped, so I know confidently that a is greater than 0. But now I know that this a value is equal to 3. Okay, let's try a couple more just to be sure. Okay, I'm going to go -6, 6. And then what does that go to on our transform graph? That's -6, 18. -6, 18. Well, if I have, again, x, y, then what happens here? It's xy transforms to, so this is mapping notation, 3y. Okay, so how do I go from 6 to 18 transformation? I multiply by an a value of 3. Okay, so if f of x equals absolute value of x, how do I transform it to g of x based on the information that we know? Well, if we start with absolute value of x, the a value we know goes right here. So I'm going to put the a value of 3. A equals 3. Okay, and then on your own time, verify with a graphing calculator. Okay, let's describe this. This is a vertical stretch about the x-axis. Let's be very specific, by a factor of 3. Next page. Okay, part B. So we're going to do the same thing. The graph of the function f of x has been transformed by either a stretch or reflection, state the equation of the transformed graph. So we're working backwards. We're given the graph. Let's make an equation. Okay. So I'm going to start with f of x equals absolute value of x. Let's pick some test points. 2, 2. In g of x, we don't know the equation yet. What does it transform to? It goes to -2. So if we go down, again, vertex as a reference point, this looks like just a reflection. I don't see a stretch because the shapes look the same. It's just the orientation's different. So that's 2, -2. Well, x, y. How do I go from x, y to the new mapped function? So 2, -2. So from 2 to -2, what do I do? X stays the same. And I'm multiplying by -1. Oops. X stays the same. So that's -y. Okay, so that tells me my a value is less than 0. And specifically, it's equal to -1. This is a reflection in the x-axis. Okay, number 5, replacement notation. Okay, we'll do this. Replacement means literally do exactly that. Literally replace values into the original function. Okay, we'll do a couple examples. Describe what happens to the graph of a function y equals f of x after the following changes are made to its equation. State the transformed equation. Okay, replacement, x to 6x. Okay, this is replacement notation, not mapping. Remember, mapping is, think about yourself using Google Maps. You're on a map where you're looking at a point on the map and you want to make a transformation. Well, you go literally in the direction. So if you translate up or you stretch vertically or horizontally, you do it on the map as you say it, as it's described. Replacement notation, you're actually replacing the notation that represents the transform function into the original function. So, example, if I have a function y equals x squared, oh, let's do this. If it's y equals f of x, then it's y equals f of 6x. So literally, wherever you see an x, you replace it with a 6x. So an example would be y equals x squared. Well, hang on, folks. So f of x equals x squared. What's f of 6x? Well, that's 6x squared, and that's 36x squared. Okay, our b value equals 6. But what's the stretch factor? So the factor is 1 over the absolute value of b, so that's 1/6. So how would I write this? This is a horizontal stretch about the y-axis by a factor of not 6, 1/6. Okay? So basically all the x values you're multiplying by 1/6. Okay, next one. Y is replaced by -3y. So if I have y equals f of x, well, I do this. -3y equals f of x. Okay, and then if I divide by negative 3, I get negative 1/3 f of x. Well, that is an a value of negative 1/3. Okay, so this is a vertical stretch about the x-axis, okay, by a factor of absolute value of a, so the factor is 1/3, but then a is less than 0. There's also a reflection in the x-axis. Okay, two things going on. Okay, here's this last one. X is replaced by negative 1/5 x, y is replaced by 1/2 y. So if I have y equals f of x, well, let's replace it. So y gets replaced by 1/2 y, f of, not x, but f of negative 1/5. Okay, finishing this up, I have, let me simplify this. Let me just get everything over to the one side. Y equals 2f of negative 1/5 x. Okay, so a value equals 2, so that's a vertical stretch in the axis by a factor of 2. My b value is negative 1/5. The factor, remember b value and factor are not the same. 1 over negative absolute value of negative 1/5. That equals 5. Okay, that's negative 1/5. Okay, so what happens here? This is a horizontal stretch about y-axis by a factor of 5. This is a vertical stretch in x-axis by a factor of 2. And one last thing, folks. Reflection in the y-axis because b is less than 0. Okay, summary of stretches of the function y equals f of x. So just have a read of this. Here's the a value, a vertical stretch about the x-axis by a factor of absolute value of a. So separately, this is the factor. Then consider the a value as it's written here. Is it less than 0? Then it's reflected in the x-axis. Here's the mapping notation. A value, so multiply the y by the factor a. For a horizontal stretch, here's the b value. Horizontal stretch about the y-axis by a factor of 1 over absolute value of b. Okay, remember, b value is not the same as a factor. You have to do this to get to the factor. So this is the factor. Then you consider the b value as it's written here. Is it less than 0? If it is, then it's also reflected in the y-axis. Here's the mapping notation. Okay, divide by b. Or the other way to think about it is, right, we have to keep these two things straight. Dividing by b is the same as divide by b or multiply by the factor. Doing it both ways, doing it either way is equivalent. Okay, so in this example here, I have b equals negative 1/5. Okay, b equals negative 1/5. the factor, so negative 1/5, if b equals negative 1/5, okay, the factor you multiply by is 1 over absolute value of b, which is 1 over negative 1/5, and that equals 5. Okay, so if we're just considering a horizontal stretch, okay, so this is example, horizontal stretch, xy transforms to, okay, we can either divide by b or multiply by the factor to get your mapping notation. So x divide by b, so if I do x divided by negative 1/5, and y, that's the same as negative 5 comma negative 5x comma y. Okay, if we multiply by the factor, okay, we go 5 times x, y, but we know there's a negative sign on the b, which means there's a reflection. I throw that negative in there. I would suggest stick with this notation. You can read the b values straight from the function, so just divide all the x values by b. You can do it that way or multiply by the factor, and keep in mind any reflections like that.